is Ra, and this is my Lab 2 video report for Charge Tapes Revisited. Video contents. The purpose of this lab was to make pieces of charge tapes, observe the interactions between them, use them to calculate the amount of the charges, and represent them using a computer model as charge distributed along a straight line instead of a point charge as the last lab. Results: new charge on tape was calculated to be 6.76 times 10 to the minus 8 power coulomb. The magnitude of the electric and gravitational force were both 1.96 times 10 to the minus 3rd power newtons. Here's the preview of the experiment. In the left image, you can see the actual experiment that we did, and in the right image, you can see the computer model that I've created for this one. You can notice the electric and gravitational forces magnitudes are the same, and also the electric fields on the top tape are represented as green arrows. Related concepts for this experiment: Newton's second law, Coulomb's law, force of gravity, and electric field formula was used. The force of gravity was simplified to be F equals mass times G, which was 9.8. And charge distribution, which is charge density equals total charge divided by the length of the object. Initial conditions were tape mass 0.2 grams, length 20 centimeters, and width 1.5 centimeters. Here's the experiment. System was tape B, surroundings were tape A and earth. Distance between two tapes were 11.5 centimeters, and charge on tape was initially, from last lab, calculated to be 5.3694 times 10 to the minus 8 power coulombs. And here is the code that I wrote to create the model. When I used the initial charge, I noticed that the magnitude of electric and gravitational force did not equal each other. Therefore, I traced back the calculations and got a new value of Q equals 6.76 times 10 to the minus 8th power coulombs. And using this, I've created the code. You can see that the top tape is represented as red spheres, and bottom tape is represented as the blue spheres. And in this one, you can see that the electric fields on the top tape are represented as green arrows. The electric force on the top tape is represented as white arrow, and gravity on the top tape is represented as yellow arrows. And results: you can see that from both numerical and visual representation, the electric and gravitational force magnitude was equal, and you can see the electric field applied on the top tape as well. Discussions. For charge calculation on the initial value, I've used the assumptions like air resistance, friction, and many other factors are negligible. Long tapes are represented as a point charge. The charge is evenly distributed through the tape. However, in this lab itself, I did not use the second assumption since we assumed that it would be charge distributed along a straight line. The possible sources of error for this lab are assumptions not being true, especially the point charge one. Human errors such as misreading graduations on the ruler and etc., and discharge due to contact with human hand were also considerable. What if you had modeled each of your tapes as a single point charge like in the previous lab? When I modeled my tape's charge as a single point charge in the last lab, I've got 5.36 times 10 to the minus 8th power coulomb. In this lab, where I modeled it as multiple charges distributed along a straight line, I got a charge of 6.76 times 10 to the minus 8th power coulombs. And these estimates differ because Lab 2's model is closer to real life, because in real life the charge is distributed along tape's area. In Lab 1, the distance between particles are more different in this one from the real life. Therefore, Lab 2's model is closer. Conclusion: successfully calculated the magnitude of the electric force on tape using electromagnetic principles, and successfully recreated the experiment, updated using a computer model. Thank you.